Hi, today we will start with topic current and resistance. First of all, I will explain about what is current and what is resistance, what device that measure resistance. So, first of all, electric current. What is electric current? What is current? Current is the rate at which the charge flows through the surface. Surface means, for example, this is wire. So current flow inside the wire, right? So what is flows inside the wire? The charge flows inside the wire. Okay. What charge? Negative charge, electron charge. Okay. Okay, so the equation how to find current? Current is equal to charge over time. Delta charge over delta time. Change of charge or change of time. Okay, SI unit of current is ampere or coulomb per second. Coulomb per second because charge over time. C over S. Coulomb per second. Okay, next, resistance. What device measure resistance? Is resistor. We call as resistor. Okay, resistor measure resistance. Okay, what is the function of resistor? In all circuit there will be resistor. Why? Very good. To control current from overflow. Okay, if the current overflow, there will spark or whatever. Okay, explode. Okay, so resistor is the function of resistor is to control current from overflow. So did you familiar with this? This is what we call Ohm's law. V is equal to IR, or R is equal to V over I. So you just rearrange. Okay, unit of resistance are ohms. Okay, R is resistance, V is voltage or battery or potential difference, I is current. So the unit for resistance is ohm. This is the symbol of ohm. Okay, next, resistivity. What's the difference between resistance and resistivity? Resistance is the measurement from resistor. Resistor measure resistance. So resistivity is the resistivity of the material. Okay, resistivity of the material. Each material has their own resistivity. For example, aluminium. Aluminium have their own resistivity. What else? Iron have their own resistivity. So each material have different resistivity. Okay, we can calculate resistivity by using this equation. R is equal to rho L over A. R is resistance, rho is resistivity, L is length, A area. Every symbol here you have to put in SI unit. Meter, meter squared. Area, what area is this? Okay, for example, wire. Length of the wire. Area of this. Area of the cross section of the wire. Okay, resistance in the wire. Okay, so wire you have copper, aluminium, iron. So it's different material, you have different resistivity. Okay, clear? Okay, now we learn how to look how current flows. So this is the battery, this is the wire, connect with the resistor. Okay, so electron flows from here. Current flows from positive to negative. Please remember that current flows from positive to negative. So current flows here through the resistor, through the negative charge of the battery. Okay, rate at which the energy is lost is the power. Power is the rate which energy is lost. Energy lost we call as power. So power, P is equal to Q over T V. Q over T is the current. So Q over T V, you can use this equation, is equal to IV. I from Q over T. Okay, IV, you just expand the equation, you will get, you just derive the equation, you will get this one. Okay, if you don't have current, you can use power is equal to V squared over R. If you don't have voltage, you can use P is equal to I squared R. If you don't have resistance, you can use P is equal to IV. Okay, unit for power is watt. So at your calculator, is there any power here? Look at the back of your calculator. Power is equal to 0.0001 watt. So it's very small power for this calculator. Okay. If you use solar power, solar calculator, there will be different power. Okay, and the last one in this topic, same with the capacitor that you learned before, which is a combination resistors in parallel and series. Previously, you learned capacitors in parallel and series, right? So, in capacitor, the equation is C is equal to Q over V. So, we will look at capacitance, equivalent capacitance, how the charge flows, how the voltage flows in the circuit. Now, for resistor, we relate with Ohm's law, which is V is equal to IR. Okay, V equal to IR. So we will, for parallel, how to calculate R equivalent or equivalent resistance or total resistance or effective resistance. And this is how you calculate parallel equation, a parallel circuit. Use this equation 1 over R. Previously at capacitance, parallel, you just add all. Okay, so it's vice versa from the resistance circuit. Okay, so voltage for each parallel circuit should be same. For example, voltage here is equal to 4 volts. So voltage come to R2 and R1 also 4 volts, 4 volts. But the current flow are different for parallel. If the current flow here, for example, current flow is equal to 3 ampere. 3 ampere. So 3 ampere, there's a junction here, right? That's why we call as parallel. So I1, for example, 1 ampere, I2 is 2 ampere, for example. Okay. Okay, but in series, the current flow same for all. Same. The current flow same for the value of current flow are same. Okay, for example, the current flow is 5 ampere. So 5 ampere go through R1 and 5 ampere also go through R2, but different voltage for each resistor. Okay, because current flow is different because they control the overflow current, right? So the voltage will be different for each resistor. Okay, in the next video we will discuss about example. Thank you.